All right, now we're going to write some code. This is the fun part. If you've been scared or worried about this, don't be. It's going to be a blast, and it's not going to be too complicated or anything too hard to understand. You'll see that the code that we write is relatively simple to get the job done. We don't have to do anything really complex or confusing, and you don't have to understand a lot of math or anything else. We're just going to write some simple code to handle input and make a bird go flying. So to get started, we're going to need a code editor. Now I'm on Windows, and the default editor in Windows is Visual Studio. It's Visual Studio Community. Let me show you where that's set before I open it up. If you go into Edit and then go to Preferences, drag your Preferences window over, you see an External Tools section. Now this changes every version a little bit, but it should look something like this. Over here, you'll see an external script editor. I'm using Visual Studio Community. Writer is another great option by JetBrains. I use that all the time. You can also use a different Visual Studio editor or Visual Studio Code. If you run into problems and you're not seeing things like auto completion or your project isn't working right, make sure that you come into this section and hit the regenerate project files. That will usually fix the issue. If that doesn't fix it, try closing Unity, reopening it, regenerating those files, or even rebooting. Sometimes we run into weird issues, things get out of sync, and you just got to do a quick reboot. But normally, if you have a problem where you can't open the code editor, this regenerate button is enough to fix it. Okay, enough about that. Let's talk about actually writing code. So to write some code, we're first going to need to create a script. And to create a script, I want to put a folder in here first so that I have a place for it. So I'm going to go to my assets folder. Here we go. Just left click there and right click on our assets folder in this gray area. That's going to bring up this creation dialog, or it's really a dialog with a lot of options. But the one I care about is create up the top, and I'm going to hit folder. We're going to create a new folder, and we're going to call this scripts, S-C-R-I-P-T-S with a capital S. It's a very common folder name for Unity code files. Expect to see it in just about any Unity project that you see. Some people may name it something different, but the default is just going to be scripts. I'm going to hit enter and go into that folder. Now I've got this empty scripts folder. I'll right click again, hit create, and we're going to choose C# script. That's the language that we're going to write all of our code in, C#. Unity used to support some other languages. It no longer does, and you don't need to worry about anything other than C#. So we're going to choose C# script, and we're going to name this script bird. I haven't hit enter yet or anything else, so I'm just going to type in a capital B-I-R-D. Make sure that you capitalize the B and get the casing right. Otherwise, you're going to notice some errors and issues, or you might later, because the language is case sensitive and it's going to create a file and a class name that matches. So I'm going to hit enter. If you named it something else or you left it in a lowercase b, just hit delete, clear that thing out, and then go in and recreate it again. So just right click again, create, C# script, capital B-I-R-D, and then enter. Now I have my bird script. And here you can see a little preview of the code. You can't actually edit that code though, and that's definitely not how you would want to. So we're going to open up our code editor now, and we can do that usually by just double clicking on the file. Here we go, Visual Studio has launched, and it's way too big, so I'm going to shrink it down. Now, if your Visual Studio doesn't launch like this, you don't get it open, or it doesn't happen, again, you can regenerate project files, or watch, I'm going to close this real quick. You can also go into game object, or no, assets, sorry, and then open C# project. That should also force open the Visual Studio project. It might not take you directly to the file though. So if it doesn't take you to your bird file, just go back into Unity and double click on it again. Or you can go to the Solution Explorer window, which might be over here to the left, depending on how your Visual Studio is set up. And then you can expand it out, go to Assets, Scripts, and find your bird there. All right, now that I have my bird script open, I want to talk about what all this is, because if you have never seen C# before, this probably just looks like a bunch of random words. Oh, looks like I've got an update. I'm going to ignore that for now. So let's zoom this in and take a look at what this code is, what it's saying, and then make some modifications to it. So I'm going to hit my zoom a little bit, just controlling the mouse wheel to zoom in on Visual Studio. And up at the top, I have two grayed out lines. These are grayed out because they're actually lines of code that aren't used right now, so I can just ignore them. This next line here is what's called a using statement, and it really just says, hey, that this code or this script is going to use some stuff from Unity's engine. We're going to use some Unity specific code or objects, and we need references to that. So it's saying, hey, when you build this thing or when you do your compilation, just know that I need Unity for this. Now, that thing that it needs is this mono behavior part, but we're going to talk about that later. First, what you want to notice is that we have a public class named bird, and that matches up with our file name here, this bird, and the casing matches as well. If that doesn't match, if I misname this or I rename this or I put in the number 4 there, I'm going to get errors. My game won't work. It won't even start. I need to make sure that they match and that they match on casing. Underneath that, we have a void start and this little green section, which is a comment. This 2/ part means, hey, this is a comment. It's not actual code. It's just a note for the person that's reading the code, not a note for the computer of anything to run. So here it's just a note saying that start is called before the first frame update. We'll talk about what that means later. It just means really that it's called once at the beginning before update. Now, we'll dive into details later. The update down here is a little bit different. This is called once per frame. So it means that every frame, if we run 100 frames a second, this will get called 100 times a second. What that means is that any code that we write that we want to run every frame, things like handling input or watching to see if we shot at something or if we got too close to something or maybe it got close enough for a collision, those types of things we would do in an update. The collision would be a little bit different, but we'll talk about that again too as we get a little further on. So let's start by writing some code here. The first bit of code that we want to write is going to deal with stopping our character from falling. I want to make it so that when we start off our game, our bird doesn't fall down, so that it sits still and then we can drag it around and then launch it just like an Angry Birds type game. So what we're going to do is add in a little bit of code in the start method. So to do that, we want to go down to line 10 right here, which is in between these braces. These braces define everything that is run during our start method. So when this object's life starts up or when our bird starts, the code inside these braces will run. Now the code that we want to write is going to access the rigid body component and tell it to become kinematic. Let's go look at what that looks like in the editor before we write the code for it. So I'll go to Unity and I'll select my red bird. And if I expand out my rigid body 2D, remember these arrows allow me to collapse and expand things. I'm going to collapse this info. I think it's a little bit useless. And if I look at my simulated option, what I can do is uncheck this and hit play. Watch what happens to the character. He doesn't fall anymore. If I check it and uncheck it, you can see that he starts falling and then stops falling. So what I want to do is make it so that he doesn't fall by default, so that he's essentially not simulated. In a 3D context, we would be toggling the kinematic state. Here we're going to toggle the simulated state of this rigid body. To do that, we'll go right back to this line 10, and we're going to write in the word get component, and we're going to add in the less than sign, that's shift and comma, or the key right next to M, and we're going to put in rigid body 2D. Now, I'm getting good auto completion here in Visual Studio, and you should as well. If you're not seeing that, again, go back into the editor, go to the project settings part, edit, and go to, preferences, and go to external tools and regenerate those project files. You should start to see it show up. If that doesn't work, then make sure that your Unity is updated and that your Visual Studio is updated too. Sometimes they get out of sync. All right, so now I've got my method, get component, and I've got this less than rigid body 2D greater than. What that really means is get the rigid body 2D component. This greater than, less than around it is what we call a generic type, and it's saying get a component of this type. Now I need a open and close parentheses, so I do Shift 9, Shift 0, and that says, hey, actually execute this. So after every method call or everything that we want to run, we do an open and close parentheses, and sometimes we put parameters in there. So if this was going to take a parameter, I would put it there. Get component does not, though. So I get this component, and then I put a dot, because that's going to get me a reference to it, and then I can do something to it. Now, if I scroll down here, I should find something for is kinematic or simulated. Now, we want to choose the kinematic option and not simulated, primarily because we want to be able to interact with this object through our player when it's still not moving around or when it's not falling. So we're going to choose is kinematic, and we're going to set that to true. Now, is kinematic just means that, hey, it's still simulated, but it's only controlled or moved by us or by our code, and it's not moved or controlled by physics objects or the physics system on its own. So we'll save that off, and we'll go into Unity, and then let's hit play and watch our bird. He should no longer fall, but stay simulated. Look at that. Now I want to make it so that our player can interact with the bird. We're going to set it up so that we can tell when our player has started clicking on him and get him ready to start clicking and dragging. I think we'll start by just tinting him a different color and then maybe make it so his eyeballs close. So to start with a different color, we're going to do something on the sprite renderer. Right now I'm in play mode, so my changes won't be saved. Watch as I change the color of this guy in play mode. So here I've clicked on the color, and I'm going to go over to maybe a yellow and then just drag over here. And look at that guy, he just turned yellow. If I go around the color wheel, you see he goes green, bluish, kind of a pink, and a red. I'm just going to go with like a red for now. And what I want to do is make it so that when I'm clicking and holding down on him, he turns red, and when I let go, he turns back to his normal white color. I'm going to stop playing just so you can see that the color got reset. If I'd done that in edit mode though, and gone like that, it would stay stuck in red, and I'd have to go back over to white and just change the color back. Okay, now let's go write the code to make this happen at runtime when our player clicks on the character. So to do that, we'll open up our bird script, and we're going to add in a new method. We're going to add in an onMouseDown method, and this is a built-in part of Unity and part of this MonoBehavior class. So to do that, we're going to go right here to line 12 and add in an extra line. I'll add in 2 lines, and then I'll go up to line 13. I want to have a little bit of space between my methods. I'm going to type in the word void, which means no return type or don't give us back anything. We'll talk about that later. And then we're going to add in the words onMouseDown, and it should autocomplete for me, but if it doesn't, you can just type it all out with an open close parentheses and then add in the open and close braces. It automatically added them for me, and it automatically added this private keyword. I'm going to remove the private keyword because I don't necessarily need it. It's private by default, and that just means that it can't be called from another class. We don't have any other classes. It doesn't really matter, but I'm going to get rid of it to line everything up and make it nice and short. Again, it's just telling us that it's the default. I don't necessarily have to have that there. It doesn't make any technical difference. So onMouseDown, what do we want to do? We're going to change that color of the sprite renderer. So just like we got the rigid body 2D component, we're going to get the sprite renderer component. So say get component of type. I'm going to hit down arrow and enter, and then hit the less than key because the down arrow one didn't do anything different for me. And I'll put in sprite renderer with a capital S and a capital R. Open close parentheses after the greater than sign, and then a dot at the end. Now this is where I get that pop-up to allow me to see the different properties on there. Look, there's a flip Y, a flip X. You might have seen those on the sprite renderer. And if I keep going up, you'll see the color. And I'm going to set this color to something. So to do that, I need an equals, which means we're going to assign it. And I want to assign it to a built-in color. Now there are 2 different ways that I could do this. I could just say it's equal to a new, and then put in the word color and an open parentheses, and then I can give it a value of like 1 for red, 0 for green, 1 for blue, and let it create that color so that it's 100% red and blue and 0 green. What's that going to come out to? Like a purple. Or I can use this other shorthand, which is color dot, and there are a bunch of built-in ones. So I could use white, green, red, blue, black, clear. I'm just going to go with red and make it really obvious. So I can say color.red, which is just a built-in one. I'll save that off, and I'm going to go back into Unity and try it out. Remember, it's Control S to save, by the way. Get used to that hotkey. You're going to use it all the time. So hit play in here, and I'm going to click on my bird, and look at that, he turns red, and then I'll let go, and he stays red because we haven't written any code to turn him back white. So let's go back into our code and add in the code to make him white. We'll open up our bird, double-clicking on that script, and we'll add in an onMouseUp. To do that, I'll say onMouseUp. Notice I didn't even type in the word void. I just started typing and let it autocomplete. I don't even have to worry about the casing if my code editor is working right. And then I can hit enter and let it generate. If it doesn't generate for you, you may have to just go in and type it all out. But I'd recommend getting your auto completion working if you can. I'm going to delete this private keyword, just double click on it and then hit delete twice. And then we'll add in a onMouseUp method or handling of the onMouseUp. So I want to do the same thing that we're doing here, except turn it to white. And I don't want to type because, hey, typing takes time and I can just copy this and make it faster. So I'm going to click here, drag to the end, hit Control C to copy, then I'll click here on line 20 and hit Control V to paste. Nice and short, save myself some time. And now all I have to do is change this word red to white. So now onMouseDown, we'll change it to red. onMouseUp, we'll change it to white. Let's go try that out. Go into Unity. We'll hit play. Click, he's red, and let go, and he's white. So there we go. He's turning red when he's charging up and white when we're going to launch him. We're getting there. We're almost to the point where we can start launching this bird off. Next, we need to make him actually move around when we drag our mouse. So to do that, we'll stop playing again, go back to our bird, and add in another method. This is going to be an on mouse drag. Just like on mouse up and on mouse down, there's an on mouse drag. So hit enter 2 more times and type on mouse drag. And I'll get rid of that private keyword again. Just double click and hit delete twice. And then here, what we want to do is move our bird to wherever our player's mouse is. To do that, we're actually going to modify the transforms position. Let's go take a look at that real quick. In Unity, remember, we have this transform right at the top of all of our objects. If I click on any of these, they all have this transform. It has our position, rotation, and scale, the 3 kind of key things that any object in 3D space is going to need. So what we want to do is move the position of this in code to match wherever our mouse is. To do that, we're going to use our camera here, this main camera that has this main camera tag on it. If your camera does not have this main camera tag, this code is not going to work. So you'll need to make sure that you have your camera tagged as main camera. That's the default. It would only be different if you've changed it. All right, let's go into the code and write the code that we need. So on mouse drag, we want to figure out where the player's mouse cursor is, like where that position is. And then we just want to move the bird to that position. So to find the position, we need to set a vector or a variable to store this in. So we'll say vector3, which is a 3D positional vector. It's an X, a Y, and a Z. We can use it for position or other things. In this case, it's used for position. And we're going to call this mouse position with a lowercase m and a capital P, because that's called Pascal case, or sorry, camel case. That's camel case, and that's what we generally use for variables in C#. If it's a variable like this, something that we're using inside of a method, we use this camel case, where we start with a lowercase and then use an uppercase letter for every word after that. So we have a mouse position. We're going to assign it to camera.main, which is going to find that main camera in our scene. It actually does a search by tag, and it looks for all objects tagged with the main camera and finds the first one that's a camera tagged with that. And we want to use the screen point to world point method. So we're going to select screen point to world point and then do an open parentheses. And what we need to give it first is a screen point for our mouse. So to do that, we go input.mouse position and then add a semicolon at the end. So this is actually just going to give us the mouse position in world space in our game, just off of our main camera. Again, this only works if our camera is tagged as the main camera, so it knows what camera to use. It's one of these nice built-in methods to find positions and map things, so that you don't have to do all of this math yourself. So now we've got our mouse position. We just say transform.position equals mouse position. Save that off. Make sure we've got a semicolon at the end of each of those, and then we'll go back to Unity and hit play. There we go. I click and I drag it around, and look at that. My bird totally disappeared. Let's see why that happened. I'm going to go select my bird and look at him. Well, let's stop playing. Go select the bird and then hit play. And let's look at him in the inspector. So right now his position is at almost -6, 1.8, and 0. I'm going to click on him and look at that. The -6 and 1 values look good, but look at that Z. The Z actually changed to a -10. I'm going to click on my camera. Notice that that's also at a -10. Let's stop playing and think about what's happening here. We're doing this shot into the game or into our scene from our camera using this screen point to world point or screen to world point. And it's giving us a point for where we're clicking in here, but it's using the camera's Z position because our game is completely flat. So we need to set the Z position back to 0 or leave the Z position alone. So we'll go back into our bird code, just double click on my bird script here. And when we set the position, instead of setting it to this mouse position, let's set it to a new vector3, and we'll use the mouse position's X value. So I do mouse position.x as the first parameter, and I'll put a comma here, and this allows me to do a second parameter of a vector3. So here I'm just creating a vector that's got an X and a Y value that match our mouse position, and then we're going to leave the Z value alone. So say mouse position.x for the first and mouse position.y for the second parameter. And then for the third parameter, we'll just use transform.position.z. So that way we're using our own Z position. We never move it, and we only move along the X and Y values. I'm going to save that again, go back to Unity one more time, hit play and try dragging my bird around. Look at that. He drags around and now goes wherever I want. And if I let him go, I can just kind of place him and move him on the screen. So, I mean, you might have a game now. Oh, look, I dragged him behind the ground. So that might be something I want to address. But right now, that's a ground piece that he'll hit. So I don't really need to worry about it. I'm going to stop playing, let him reset, and then we'll get into adding some more stuff to him.